Welcome to Space and Time's first podcast. Really exciting guest to kick things off. Longtime friend of mine and one of the leaders in the space, a thought leader and technologist in the data warehousing space, the CTO, Chief Technology Officer of Teradata, Stephen Brobst. Great to have you on the podcast.
Thanks, Scott, for having me in your inaugural podcast. Happy to be here and happy to talk about data. Always happy to talk about data.
Easy. Stephen, as one of the kind of earliest leaders in this space, one of the kind of founding technologists around large scale, I would say enterprise scale data warehousing, tell us a bit about yourself, your background, and especially the history of data warehousing and how we got to today.
Well, about myself, I guess my whole career has really been as a data geek. Originally, I started out in scientific computing at Lawrence Livermore National Laboratory, and that was more around sort of hydrodynamics and modeling physics and things like that, very science oriented. And then I ended up on the East Coast for my grad work, and the science labs on the East Coast aren't really as interesting as science labs on the West Coast. I'm a little bit biased, of course, but I wanted my hands on big computers, and actually the most interesting problems to solve were on Wall Street. So then I started building real-time trading systems and sort of got more into the financial world, a little bit away from science, but still very, very quantitative use of data for predicting trends in the marketplace and so on. And that kind of evolved into this data warehouse space in general. So pretty much my whole career I've been doing some combination of teaching data warehousing and building data warehousing and CTO type of work in data companies basically. So
awesome. And what was kind of your first major project in query optimization or large scale distributed systems like this?
Well, it depends, sort of how you define.
MIT?
I mean, even at Lawrence Livermore National Laboratory, it was, if you're doing these hydrodynamic simulations, we're trying to figure out how to take these, mathematical algorithms, which were fundamentally written down as a series of steps that people are executing in a sequential way, and then parallelize them. And so my PhD research was a lot about this model of computation called data flow, where you basically look at the dependencies in the algorithms and then figure out how to parallelize the heck out of them. So this is very early, massively parallel processing work, long before there were clouds and long before a lot of the technology we have today we just take for granted. Back then we were building it. It was pretty fun stuff. So I would say that was kind of the first work into this space. But the space has changed a lot. Back then, there were not a lot of, I would say, data thinking people. Everything was very application centric. And you had to convince people that data was important and integrating data was important and so on. And, in those early days, most of the teams, especially if you go into large enterprises, were very centralized because you had to get this small number of data thinking people together and kind of form a club and do things like data modeling and data governance and deploy a data warehouse so that people could get access to that data. And I would argue that as an industry, we became a victim of our own success because these centralized teams, they don't work anymore. And monolithic data warehouses, they don't work anymore, right? Because it doesn't scale. And I don't mean from a technology point of view, I mean from an organizational point of view, right? Because what's happened is we don't have to actually have discussions anymore about whether data is important. People understand and believe that data is important. And the number of consumers of data within an enterprise growing exponentially. The number of data sources that we're interested in within the enterprise growing exponentially. And then you get this centralized team who's constantly the bottleneck. And say, okay, great, add 10 more people to the centralized team. Well, above a certain scale, when you add more people to the team, you get more meetings, you don't get more output. And so this centralized team stuff doesn't work. And that's why you see in the industry right now this evolution towards a more decentralized model from an organizational structure point of view. You might have heard the term data mesh. And so you have the different nodes in the mesh. And the key is you got these different nodes in the mesh, but those data products, they need to be interoperable so that the products can be used together, because you get a lot more value when these decentralized sort of pockets of data can be used together. You get exponential value versus linear value if you just have a bunch of islands. Islands are no good. You need to bring the pieces together. Yeah.
If you don't mind, just real quick, I'd like to go back and back to kind of how you got into Teradata, your transition from research and the work you did at the laboratory, and then what brought you to Teradata, and then tell us a bit about Teradata and their business.
Sure. So, I'm a very hands-on person. So even while I was doing my PhD research, I was doing, some consulting on the side and working with people and, building systems and, getting some pocket cash to fund my travel habits, because I'm a fanatic traveler internationally. And so I built this company, largely, people that I had worked with while I was at MIT. We built a small systems integration company, and we were working with very high-end enterprises, people like Bank of America and Walmart and AT&T and those kind of folks. And Teradata acquired that company, kind of made us an offer we couldn't refuse in the late 1990s, and that's how I came into Teradata. That was a point where Teradata was actually not yet a standalone company. In fact, it was a technology that had been developed at Caltech, and then got acquired by AT&T, and then AT&T spun it off into NCR, but it was kind of spread out. There was not really a coherent vision about how to go to market and so on. And so this guy, Mark Hurd, who you may know, who eventually became CEO of HP and co-president of Oracle, sadly, he passed away due to a pancreatic cancer not long ago. But he had this vision of creating this Teradata division within NCR, consolidate all the technology and build a standalone business unit, which eventually we IPO'd. So some years later, I was part of the team that we did the IPO on the New York Stock Exchange, and Teradata today is a standalone company, kind of recognized for its leadership in the sort of enterprise scale analytics. So it's a very crowded space right now. A lot of people in the data warehousing and data space, because it's an exciting space. Journalists one time recently, they asked me, aren't you worried that you got all these competitors coming after your space? I say, look, I'd be worried if they weren't coming after my space, because that means you're in a boring space. Competitors make you better, and we continue to sort of take the number one spot in Forrester and Gartner and all those kind of things, because we've been doing this a long time, and we know how to do it very, very well.
Yeah, I think that's something that people probably outside of the space aren't aware of, that Teradata has always been a leader and continues to be a leader in the data management Magic Quadrant, and of course the cloud data Magic Quadrant from Gartner. I think Teradata's long history of innovations in the data warehousing space kind of speaks for themselves. With that in mind, kind of one last question on that. For our listeners that aren't kind of familiar, what is data warehousing in general? What are these large distributed systems that do analytics for the enterprise?
Data warehousing is really bringing the information from across the enterprise and outside the enterprise, because there's actually a lot of data that's interesting that comes from outside the enterprise, and bringing that together into I'll say an infrastructure that allows people to answer their business questions. And it's really thinking of data as a product. One of my, I'll say, pet peeves in the industry is around 10 years ago, maybe a little bit longer, people started talking about data as an asset. And think about data as an asset is totally the wrong mindset, because when you have an asset, then essentially it means you are accumulating more data, and your measure of success is how big it is. And this was one of the failures of the Hadoop era, where people were sort of dumping lots of data into HDFS and then thinking about, well, if I got more data, then that's better. And I would argue, the size of your data is a good measure of cost. It's not a good measure of value. And a much more productive way of thinking about data is not as an asset, but as a product, and start from the consumption side. The value of the data comes when you consume it to answer business questions. And so when you look at value created, look at the answers that you're creating. And if you are a mature data warehouse deployment, I would argue you have not just people in the corporate ivory tower using your data to make strategic decisions, but everybody in the whole value chain making decisions. So we talk about strategic intelligence versus operational intelligence, and the value chain may even include providing this data consumption capability to your suppliers, maybe even to your customers, and so-called democratizing the access to the data, but really thinking about data from a consumption point of view, not as an asset to store in a warehouse. We have kind of this terminology, data as an asset and data warehousing, that is actually counterproductive to a better way of thinking about data as delivering answers.
I love the term that you just used, democratizing access to data. I think that's a great segue into a conversation that you and I had. I believe it was maybe December in New York City. We were starting to talk about use cases for the blockchain and in blockchain technology as democratized access to data, but more importantly, as kind of a tamper-proof audit trail for external third parties to get democratized access to data. And I think this term of decentralization becomes so prevalent in this blockchain market. And I asked you, Stephen, like, what do you see this decentralized database that is a tamper-proof ledger that is a blockchain? What use cases do you see for that? And of course, then we'll kind of segue that into why it ties into data warehousing. But first, I kind of want to go back through that conversation with you. Use cases for this distributed ledger, this democratized access for data that you see being prevalent in the near future.
Sure. I mean, obviously, the most famous of the use cases is cryptocurrency, right? Bitcoin and all the cousins and siblings of Bitcoin. But actually, I don't think that's the most interesting one. But I think that blockchain has sometimes gotten tied up with cryptocurrency in a way that's not been good for the blockchain technology and exploring the other use cases. So I think that your point about sort of tamper-proof and decentralized opens the door to a whole bunch of interesting use cases, understanding, I would call it lineage, where if this head of lettuce that I have on my dinner table, where did it come from? Right, and there's a whole bunch of there's a whole bunch of supply chain handoffs that happen between planting that seed in a farm somewhere and then sort of bringing that head of lettuce to my dinner table. And so why should you care about that? Well, it has a whole bunch of implications related to fair trade. Did each person along the supply chain get their fair share? If there was a problem, right? You've seen in the past in the marketplace where there was some problem with meat or produce or something, and then they recall everything in every grocery store and so on, even though there's some very small percentage of a product that was actually had a problem, with this sort of reliable lineage of the birth to consumption of the product. You know exactly which product in which stores you need to do the recall. And I'm using sort of food as the example, but there's similar applications, for example, for pharmaceuticals. There's a lot of fraud in pharmaceutical marketplace, and to the extent that you can sort of track, where did the pharmaceutical come from, you can understand, is this actually a legit product that I'm about to consume? And so these kinds of applications where you have a reliable lineage, when you have many different players in the marketplace that are involved in the supply chain are, to me, very, very interesting.
Yeah, the supply chain use case is exciting. I think we're starting to see more and more kind of I guess, inventory use cases, supply chain use cases, and the non-fungible tokens that are representing actual goods along the supply chain, and the metadata associated with those being the lineage on the blockchain. What about continuing down that theme of democratized access to data? Would you ever have imagined, I don't know, 10 years ago, 20 years, I got 10 years ago, we already had a Bitcoin, but 20 years ago, the data warehousing space 20 years ago, and even today, nothing has really changed around kind of private, centralized control of data. And it's not about centralization in the enterprise. It's about privacy, data privacy, like a lot of compliance and rules like GDPR, where enterprises globally are not allowed to kind of have very strict controls around what they can do with their customers' data. HIPAA laws around what healthcare companies can do with healthcare data, PII data. I would say the data warehousing space as a whole is marked by very private data warehouses, right? Very locked down, highly kind of strict policies and compliance. Would you ever imagine, like 20 years ago, that we'd have this sort of open source, open data, everything public, democratized access to a single ledger?
Well, I think that it was actually predictable in the sense that the early innovators, they were sharing the data, right? One of my measures of maturity, I think I've mentioned this before in our discussions, is if you have more users of your data who are not your employees than those who are. And there were early companies that were absolutely doing that. But to your point, it was very centralized. Right, so they sort of created that repository, and then they provided very controlled access to the data, who got access to the data for what purpose, and how you access the data, and so on. Now it's the evolution and the awareness of data sort of introduced all kinds of things. I mean, GDPR, you mentioned, this has been around for decades. This is not a new thing, right? HIPAA, it's been around for decades. But cloud, of course, brings another dimension to the thinking. It's like, oh, okay, so actually that data is not going to be in my data center. People had this false sense of security. Well, if the data's in my data center, then I have control over it. Well, I'm not sure that's completely true. In fact, in the early days of cloud, people worried about, well, is my data safe in the cloud? And my response was, after a certain level of maturity, it wasn't true in the very early days, but pretty early on, I would argue your data is safer in the cloud than it is in your data center. And people with their eyes would open, what? How can that be? So look, you cannot possibly spend the amount of money on cybersecurity and detection and prevention and so on that someone like AWS or Google or Microsoft can do. And there's a lot of evidence out there, use case evidence where you see breaches, and the breaches are increasingly in data centers. They're not in the cloud. Of course, there can be breaches in the cloud, and it's got to be a joint responsibility model and so on. But as we globalize, one of the issues related to what you said is, well, look, if I'm a global bank and I'm doing business in 28 different countries, each one of those countries has their own individual requirements, right? And typically, private data can't leave country, right? So so-called sovereignty laws, right? And yet we need to have access to all that data. If I'm doing, let's say, BCBS 239 reporting, which happens, it's a sort of regulatory requirement to understand, overall risk that a bank is exposed to, and so on. I need the data from across the multiple geographies, but by law, I'm not allowed to bring it together. So, this is another dimension of this concept of, data mesh or data fabric. These things get a little bit confused, but I would argue that data mesh is really more about governance and organizational structure, and this decentralization largely driven by agility and organizational scaling. Data fabric is an enabling technology. But data fabric, the problem with data fabric is, people are not understanding good engineering very well. They're taking the data and they're sucking the data to some centralized hub, and moving the data to the processing is not good engineering, right? I use the term query fabric. move the processing to the data, not the data to the processing. And so that's why having sort of distributed models for the compute, where you can have the compute taking place local to the data, is very important. And then I can do the filtering, the projection, the aggregation, the joining, and so on, local to the data, and then I just bring the answer set back. That is much more efficient, and it's more compliant with some of these laws that doesn't want the private data sort of flying around and so on. So you absolutely have to protect the data, and it has to exist in a distributed world.
Yeah, I agree. And Space and Time's incubating a set of technologies to bring a query compute layer to IPFS, the interplanetary file system, that decentralized storage layer that maybe is analogous to a decentralized blob storage or a decentralized S3. Of course, that's not a great analogy, but Space and Time is incubating some technology to bring that query engine, that query layer, the compute layer, to that data in IPFS. But I just wanted to quickly kind of touch on a thing you said a few minutes ago on organizations providing access to third parties outside their org. That's maybe analogous in the Web3 world with kind of private permission chain. We see like new technologies like Polygon Nightfall, which is a privacy-focused chain that rolls up data to a public chain in a kind of private way. And we're starting to see organizations build private permissioned enterprise use cases on the chain, which to me at first I laughed because as I watched this growth in the industry of private permission chains, I thought, well, doesn't that kind of defeat the purpose of using a public distributed ledger? But then new use cases around third-party settlement systems where an organization needs to actually do exactly what you just said, which is a common practice now in the cloud-based data warehousing world of organizations providing permissioned access to third parties outside their org for things like settlement systems, of course, like an organization that wants to pay a number of third parties but needs to provide reporting to them about what they're paying for, thinking about like trading systems, TradeFi, ticketing systems where, after an event, you want to pay out all the different event organizers based on the ticket sales. We're seeing these new use cases, and those enterprises have a lot of data that actually may include PII, maybe or some kind of private information, or even sensitive financial information about the organization, where yes, they want a tamper-proof distributed ledger, and those third parties that are getting paid especially want a tamper-proof distributed ledger, because then they know that the original kind of organization that set it up is paying them the right amount. But the data is kind of sensitive. It might be sensitive financial information, as I said, and so they still need kind of private permission access. So a little bit analogous to the data warehousing world in the cloud, where organizations are using these, very large scale data warehousing systems to give permission access to data. Thinking about then other use cases around compliance. I think, you mentioned, hey, Scott, GDPR is not new, HIPAA is not new. Do you see a need for new, or I shouldn't say need, do you potentially see additional laws that are coming into the blockchain and crypto space, also kind of, allowing government organizations and regulators to use the blockchain as a tamper-proof ledger for compliance purposes?
Yeah, so typically the regulation doesn't tell you how to do things, it tells you what to do. So I view blockchain as a tool to sort of meet regulatory requirements when it makes sense to use it. And the blockchain technology is, of course, going to continue to evolve. And one of the areas where I think is going to be pretty interesting as part of the whole Web 3.0 discussion is individuals like you or I reclaiming our data. Right. So look, why is it that these big monster enterprises can collect my data and they're monetizing my data, and I'm actually not getting fairly compensated? Yeah, they probably gave me some service that they used as some way of collecting my data, and I may or may not be aware of the level of detail that they're collecting, and then they're reselling it. And that, yes, there was some term and condition that allowed them to do that, but of course nobody reads those terms and conditions. So there's a lot of stuff going on there that consumers are not necessarily fully aware of, but I think they're becoming more aware. And part of the promise of Web 3.0, at least sort of one of the arms of discussion, is, look, this data about myself, that's my data, right? And I'm going to reclaim my data. There's a movement that started in Silicon Valley, and a journalist for Wired magazine, Kevin Kelly, this idea of quantified self. right? So everything you do, this is your data, and whether it's your buying patterns, or what movies you watch, or what books you read, or what movies, your purchasing patterns, your preferences, all those things, that's my data. And I'm willing to share it, but I'm not willing to give it to somebody else just so they can go monetize it. I need to get my fair share of that. I'll share it for a trusted vendor that's going to make me better recommendations for music I want to listen to or products I want to buy. Fine, but they get to use it for that purpose and that purpose only. And if I decide that they're not using it in my best interest, I will take away those permissions to use it. And so there's this whole set of applications of this quantified self kind of data that are going to emerge, and you're going to see this. This is hugely distributed, right? Imagine every person in the world is a little node in the data mesh, right? And it's all about their data. And now you want to actually create insights about behaviors along lots of different dimensions, whether it's health or music or whatever. Very, very interesting use cases in the Web 3.0. Now we're far away from that happening now, but you can see the startups starting to emerge, and this is going to be a rich space.
Yeah, I think people in the space and outside of space don't actually realize that the blockchain itself is a new kind of database. It's a transactional database that's very, very limited in storage. And it's this highly replicated single ledger. And I guess newer blockchain designs are of course doing multi-ledger, but for now, the majority of the blockchain use cases are a single table, a single ledger, highly distributed, very limited storage, very slow access to data, no query language, but tamper-proof. And that those cryptographic guarantees of the lineage of data with blocks chained to blocks through time and space, pun intended. I think that creates an interesting use case for transactions. Now, this is going to be a quick segue into what the Web 2 and really just the modern world of data processing and data architectures looks like, right? This idea of developers deploy a transactional database that serves very low latency tactical queries and handles transactional consistency in a very low latency way to power applications. They deploy databases and then often use ETL tools or data management tools to kind of stream or move data, migrate data on a batch basis from those transactional databases into a data warehouse or a data lake or any of these new data terms, but large scale distributed systems that can do with much more memory, much more compute, many more nodes often, to do analytics, to answer the bigger questions. And it's a different type of workload. This database transactional workload is more about writes and securing and locking those transactions in, whereas the analytic workloads are asking the bigger questions, the predictive questions, the processing of many tables together. So the reason I bring this up is I'm about to ask you about some trends in the data warehousing space, but what we see is that same kind of tie of data warehousing in Web3 being an analytic workload and the blockchain itself being a really simple transactional database. Not simple in terms of the design, simple in terms of the use case. Transactions being stored and very simple data sets being retrieved without a query language. Storage and retrieval on-chain of transactions and a single ledger of those transactions. Whereas space and time, the first decentralized data warehouse built for those kinds of use cases, is a analytic system to process larger amounts of data. Now, turning it back to you, Stephen, what trends are you seeing in kind of this next generation data warehousing space? And that doesn't have to be just Web3. I'm curious, Web2, any web, right? What are the trends that you're starting to see? What does modern next generation data warehousing and data lakes look like? And then maybe how could transactional systems like a blockchain be, tied into that?
Yeah, so it's interesting that one of the points that you raised is, no query language. And if you look at data warehousing as it emerged, the fundamentals of early data warehousing, largely descriptive analytics, sort of understanding what's happened historically, being able to do some drill down, understand why it happened, and so on. And the lingua franca, for decades has been SQL, structured query language, very simple language for accessing data. Most of the business intelligence tools generate SQL and so on. But what I observe in the marketplace is the descriptive analytics, it's still there. You still need it for your regulatory reporting and this kind of stuff. But what we're doing is evolving towards more predictive and prescriptive. So it's great to know what happened, but if you spend all your time looking in the rear view mirror, your car is going to crash, right? You need to look forward, and you need to predict what's going to happen, and you need to sort of decide based on what's going to happen, what are the actions I should take? And I will tell you that SQL is not the best language for doing prediction prescription. And so one of the beautiful things about the original sort of architecture of the Teradata system as it came out of Caltech, it really actually wasn't initially really a SQL engine per se. It was a parallel harness for executing any language you wanted, and SQL is just the obvious first one to do. But what we're seeing now, getting back to your question, is not just SQL as the language for manipulating the data. So as you move to predictive and prescriptive, it becomes much more about machine learning and deep learning. And yes, SQL is certainly interesting for doing the wrangling of the data and preparing the data, but I want to be able to execute Python and R and maybe Java, all kinds of languages. So you need a lot of flexibility for how you're accessing the data. You don't want to be trapped into a single language or a single ecosystem even, right? You need to be able to pull in, to leverage the cloud ecosystem to get things to work together. And so that's one core point keying off of what you said. The other thing I'll call out is, blockchain as I'll call it a bookkeeping system. And it's a distributed ledger. It's a bookkeeping system, right? Bookkeeping systems need, as you said, low latency transaction commits with high concurrency. And that's a different workload than doing, descriptive, predictive, prescriptive analytics. It's a very different workload. In one case, it's all about, being able to do these low latency, write commits. Very write-oriented workload, whereas analytics is very much a read-oriented workload. Of course, you have to get the data in, and you have to be able to do your data ingest and have the streaming and so on. But it is a different workload. And I've been asked sometimes, why do you think Teradata is a better database than Oracle? Well, actually, I don't think it's a better database. It's a different database. And you have to look at what is the use case that you're trying to do. So, I would not recommend that you use Teradata for, the bookkeeping for your core banking system. That's what transaction processing databases are very good at. For the analytics, that's what Teradata does very well. But we also have to be a little bit careful, because not all analytics have to be these big, long-running, quote-unquote, strategic intelligence. Increasingly, there's a lot of operational intelligence that needs quick in and out answers. That is still different than doing the bookkeeping in a transactional system. So you've got these trade-offs between, are you biasing towards a read orientation? So we'll invest a little bit more to put the data in order to get it out an order of magnitude faster. And Oracle is not designed for the analytics, but they're very good at the bookkeeping part, right? So, yeah, they're trade-offs.
Yeah. I think the different architecture and those different trade-offs, it's not a great analogy, but in the Web3 space, also a very, very competitive space of a lot of different types of blockchains, a lot of different architectures to do different trade-offs. In the same way that the database and data warehousing space, there's a lot of different players building different architecture with different trade-offs. People say, okay, just like you said, well, why do you think Teradata is a better database than Oracle? Well, it's actually just a different architecture with different use cases in general. People in the Web3 space, well, why is Ethereum better than Solana, or why is Solana blockchain better than Ethereum? Well, those trade-offs are actually about decentralization versus transaction speed, right? Ethereum being highly highly decentralized with thousands and thousands of participants in securing and ensuring that distributed ledger. But of course, then that comes with a speed trade-off. Solana being
and a cost trade-off. Yeah, absolutely.
Yeah, expensive and slow, but extremely tamper-proof and decentralized. Solana being much less decentralized, but very fast transaction commit. That kind of trade-off that you would make in terms of security versus transaction speed and decentralization. But going back to what you said on this, the use cases of transactions versus analytics, and in the Web3 space, the transactional database, albeit very limited, very storage limited, no SQL engine, right? Only storage and retrieval of those transaction commits, that blockchain being the transactional database, and a data warehouse like space and time being the way to the query language for the blockchain. What about hybrid architectures? We call it HTAP, hybrid transactional and analytic use cases. Do we see that often in Web 2? And if not, why has that been a struggle for developers to build a great HTAP solution?
Yeah, I mean, HTAP has been talked about for a long time, and this hybrid transaction analytical processing, you have to grapple with these trade-offs, right? And at small scale, it can work pretty well because you can bring the data into memory, and then you can do in memory all things are fast, right? And that works great as long as the data set is small. So SAP is an example. Had this database called HANA, and HANA was used as kind of a basis for this HTAP type of approach. Was not wildly successful because it couldn't handle at scale. So say, look, memory is going to get cheaper and cheaper and cheaper. And that's absolutely true. We can talk about Moore's law and the cost of memory going down over time. All those things are true. But I call this marketing math, because in real math, you have two sides of any equation. So one side of the equation is that the cost of memory is going down. The other side of the equation is the data is growing. And data grows faster than memory gets cheaper. And so that means at enterprise scale, you have to be really smart about what data that you put in memory. Putting all data in memory is actually not very good. So you have to figure out, okay, how can I be smart about getting the right data in memory, recognizing that a small percentage of the vast amount of data that you have actually is going to be used on a regular basis. So you have to have very advanced techniques using machine learning and other techniques to figure out what data goes in memory, which has low cost per IO, versus what data goes into, for example, object store, which has a low cost per terabyte. And you really need both, right? If you're going to have the kind of architecture that you're referring to, and that requires a lot of smarts.
If you don't mind me jumping right in there, I'm so glad you brought up that the marketing math of data growing faster than memory is getting cheaper. We have a similar thesis or similar approach to space and time. Our designs for space and time also assume the aggressive, cost decreases of memory over time. But we're trying to marry that with cheap storage layers underneath and intelligence that puts the hottest, most frequently accessed or freshest data in cache and memory, and kind of layers of storage temperature that moves less frequently accessed data down to IPFS, that kind of decentralized and much more cost-effective storage layer. A lot of work still to be done, and a lot of engineering for us to get there to very efficiency. But that would allow space and time to handle those very low latency kind of point record lookups. Show Scott's recent transactions on Polygon in 0.08 seconds or 0.1 second, right? And also those bigger questions of, hey, let's bring terabytes of data together in a single question, a single query that says, show me all users like Scott who have done these types of transactions on these blockchains, join with some of the actual smart contracts that they've interacted with. And our goal is not to replace the blockchain as a transactional system of record for the actual, financial transactions that the blockchain secures. Our goal is actually to have a transactional system that can handle all the metadata associated with them and rights that will eventually get committed to the blockchain, essentially like a rollup, like a layer 2 that rolls up to a main chain, but rolling up data. For example, in a GameFi use case, a blockchain-based video game, you might have a weapon, a sword that's an NFT. And as you play, your sword gets more powerful and it levels up. Well, sure, that's a token, a non-fungible token that's been minted on the blockchain that belongs to my wallet and my wallet only. But what about all the metadata about the level, the ranking of that sword? Like as I play the game, that metadata has to be stored somewhere. Some use cases, some developers are trying to write that data to the blockchain, but once again, the blockchain doesn't have a query language. So then how does the video game quickly access that data and aggregate that data and manipulate that data around the metadata of that NFT? Space and time adds that kind of query language and the extra storage and the processing needed to store all that metadata about those different tokens. So, we're thinking about transactions, not so, hey, we're going to replace the transactions of the blockchain, rather we're going to supplement them. And that hybrid architecture helps to enable that. I think it becomes a pain point for developers to have to deploy a transactional database and ETL tools, extract, transform, load, to get data out of those ETL tools into an analytics platform or data lake or a data warehouse like Teradata in the cloud. But that's a golden architecture, right? That's something that's very, very well known, very well understood. We see it in almost every organization across the Fortune 5,000, right? And to your point, there might be a better way to do HTAP databases in the future going forward, especially in this Web3 space. We believe that that's actually going to be necessary.
I think the key is to make sure that, emphasize the intelligence part, right? Because brute forcing is a losing proposition. The data for a long time to come, and for my career, even for your career, you're younger than I am, the data is going to grow faster, the memory gets cheaper, right? And so you have to be smart. Brute force is not going to work in this case. That's the mistake that SAP made.
Do you think that from a blockchain architecture standpoint, that still applies? That your caution, your warning, hey, the data grows faster than the name your hardware, name part of the hardware component, the hardware stack gets cheaper. And that's not just memory, right? So from a blockchain standpoint, we've already seen the bloating of major chains like Ethereum, such that the gas associated with those chains, the costs to commit a transaction and the cost to retrieve those transactions gets fatter and fatter and fatter and more expensive because the storage is so limited, but yet the data volumes of all of these applications, thousands and thousands of applications being built by Web3 developers around the world and trying to store all their transactions on the chain has kind of gotten out of control. So we're seeing new architectures where chains are starting to archive history, right? They're archiving the history of the chain to a cloud-based centralized storage layer. It's been interesting to watch. Do you think that there's an opportunity for developers in the next 5 years to start building more interesting architectures around the blockchain that could handle larger data volumes and more memory, but still kind of maintain that performance? Or is that going to be a significant challenge?
I think there are going to be some challenges there, but that's what you like, right? I mean, so 5 years is a long time. There's a lot of time for innovation. Right now, here and now, that would be a hard thing to do in a cost-effective, scalable way, and so on. But that's why startups like yourselves exist, right? Is to go tackle those problems and come up with interesting solutions.
What about from a you mentioned, hey, as the data volumes grow, this HTAP architecture that was kind of attempted, in the last 8 years or so, never really caught on in a massive way in the enterprise world because of that, data growing faster than memory gets cheaper. Which leads me to another, maybe one last question about the space that you're a thought leader in, data lakes. Data lakes have become such a prevalent term in the, last 4 years. We've seen that come up, right?
10 years, actually. I always say data lakes kind of came out coincident with the early evolution of Hadoop, because Hadoop on-prem, the original data lakes were largely on-prem. Kind of data lake 1.0, I'll call it, was Hadoop on-prem. Now there's kind of a stampede to bring all those data lakes into the public cloud, use object store. So it's a big difference between what we're doing 10 years ago and what we're doing now.
Fair enough. And our are you seeing, new use cases where data lakes becomes something you mentioned earlier, right? Touching on a point you mentioned earlier, that the data lake being a storage foundation on top of cloud object storage, but bringing a query compute layer to that data, bringing the processing to that data where it resides. Do you see that happening in the blockchain space as well, where, okay, so you have these decentralized networks of hundreds of quote unquote compute clusters deployed by the community, operated by the community in a decentralized kind of open community owned way. But that's a compute layer. That's a query engine that's deployed by hundreds of users in the community, deploying hundreds of clusters. But bringing that compute down to a storage layer, that's a decentralized storage layer like IPFS. What are some of the challenges that you potentially see in that kind of approach?
Well, you certainly want to bring the processing to the data, or function shipping rather than data shipping. That's just good engineering. But you also want to make sure that you've got general purpose solutions, so you don't limit the kinds of questions that can be answered of the data or the things that you can do with the data. So there have been some, startups in the past. One that comes to mind is Netezza, where they, built special purpose hardware that was, very strongly attached to the storage devices and so on. And hardware solutions are not really a great answer. They have this lifetime for 5 years or so. You'll get this kind of amazing price performance benefit, and then it kind of goes away. It's not sustainable. So I believe software beats hardware in the end, and to generalize the solution, you have to have the flexibility of software, not a pure hardware solution. So you got to be careful about that, because the hardware only approaches don't usually succeed.
Software beats hardware, and we're going to continue to see more democratized access to data, both in the enterprise data warehousing space and, of course, in the blockchain space, and with space and time, marrying the two together. On a personal note, Stephen, Burning Man's coming up in a couple weeks. I know you're a longtime Burning Man participant and leader out in the Black Rock Desert. You've mentioned to me a couple times your participation in the Rangers program. Tell us about that. Fill us in.
Well, I mean, for me, Burning Man is this week of incredible innovation, incredible people. It's an incredible culture there, and one of the pieces of culture is sort of collaboration and giving and so on. And so, when I was at MIT for many years, I was what most universities would call an RA in the dormitory. It's just to be there, not big brother like police, but older brother like friend to help you in hard decisions and so on. And so that's kind of the equivalent role that the BlackRock Rangers are at Burning Man. So it's like going back to my MIT days, being out there and just being with people and helping people and interacting with amazing people. And good innovation is not one person sitting in a closet dreaming up ideas. Good innovation is collaboration and talking with lots of smart people, with coming at you from different perspectives and so on. And that week out in the desert, to me, is it's amazing people. It's amazing art that is so large you'd never find it in a traditional museum. So it's extreme conditions. It's really hot out there. It's really dusty. It's radical self-sufficiency is one of a big part of the ethos at Burning Man. But it's an amazing thing.
Art that's too big to fit in the Smithsonian even. I know this is going to be a tough question to answer, but on the topic of amazing people that you have met, that you've known for a while, that you're collaborating with, especially at Burning Rock, what are some of the conversations? Who did you run into that you'd love to share with us?
At Burning Man, I remember, of course, Burning Man hasn't happened for the previous 2 years because of COVID. But in 2019, I remember I was walking out in the desert, looking at this amazing art, and there was this guy there that was working on his piece of art. And the art at Burning Man is there's a lot of engineering in it. There's a lot of light and fire, and it's some interesting stuff. And I was talking to him and so on, and it turns out he was like a professor of computer science at Berkeley in the AMP lab, and then they started having this discussion in the middle of the desert about what is the future of sensor data and how that data was going to be used for advanced processing and machine learning and so on, like in the middle of the desert. It was pretty incredible experience, right? So yeah.
I would say I would have loved to have been a fly on that wall, but there are no walls in Burning Man, metaphorically and literally.
Absolutely.
Stephen, it's been an absolute pleasure to have you on board. What a great kickoff to the Space and Time podcast. Thank you so much for joining us today.
Great. Thank you very much for having me.
Awesome. Talk to you soon.